we're going to discuss specific heat in relation to climate change, particularly the specific heat of water. So what exactly is specific heat? So specific heat is the heat required to raise 1 gram of a substance by 1 degree. And specific heat is relative to the substance and it's relative to the phase that the substance is in. So liquid water specific heat, as you can see in the table, it's boxed in blue, is 4.18 joules over grams times Kelvin. So this means that water requires 4.18 joules of energy to heat a gram of water by 1 degree. And if you look below liquid water on the table, you'll find water in gas form, which has a different specific heat capacity, which shows that the phases of water have different specific heat capacities. So liquid water has a high specific heat of 4.18, which is higher than that compared to other substances. So if you look at air and gas phase, for example, it has a specific heat of approximately 1 joule over gram times Kelvin. If you look at aluminum, it's even smaller. So basically all of the substances on that table except helium have a lower specific heat than that of water. So that shows, or that of liquid water specifically. So that shows how high of a specific heat liquid water has. And this high specific heat capacity of liquid water shows that liquid water doesn't get heated up easily. So water's high specific heat helps prevent the temperature of water from being raised too much. And this high specific heat of water is basically due to the hydrogen bonds between the water molecules. So the positive pole of one water molecule, which is the hydrogen, is attracted to the negative pole of another water molecule, which is the oxygen. And the oxygen is the negative pole because it's more electronegative than hydrogen. And the hydrogen bonds, which are intramolecular forces or intramolecular bonding, resist changes in temperature. So these hydrogen intramolecular bonds are extremely strong, which prevents high temperatures from breaking them up. And additionally, since humans are mostly made out of water, a high specific heat allows our bodies to regulate temperature homeostatically, as the temperature doesn't fluctuate too much with being much hotter and much colder. And there are many different importances or many different reasons why the specific heat of water is important. So for instance, one reason is that the temperature of water will stay relatively constant, allowing sea life to live peacefully in external homeostatic conditions. So this bullet point is basically referring to ocean life. So if water did not have a high specific heat, the oceans would boil and be extremely hot during the day, since the oceans are exposed to sunlight, and the oceans will be super cold at night since they're not exposed to sunlight. And this change of temperature of the ocean life, if water had a low specific heat, can have negative effects on the sea life. So the sea life is it's pretty much used to a certain temperature of water, where the water being too hot or too cold can cause certain sea life to die. So it's a good thing that water has a high specific heat capacity so that the ocean temperatures do not fluctuate too much, and the external environment for the sea life would be okay for them to live and survive in. And another importance of water specific heat capacity is that human bodies, as I mentioned in the previous slide, are made mostly of water. So having a high specific heat helps regulate our internal homeostatic conditions. And another reason that why water specific heat is important is that water is allowed to be a temperature regulator. So it cools hot surfaces and it warms cool surfaces. So water's high specific heat capacity is the reason why we can put out fires with water, because water can absorb as the heat is raised, and water does not get warm because of the fire. So fire is made out of water vapor, carbon dioxide, oxygen, and nitrogen. It's made out of some other elements as well, but these are, I guess, the main ones. And all 4 of those, oxygen, carbon dioxide, nitrogen, water vapor, keep in mind, is water in the gas form. They all have specific heat capacities that are lower than that of liquid water. And additionally, water's specific heat capacity allows humans to breathe, where water's high specific heat capacity leads to a smaller change of ocean temperatures rising, which allows sea life to live and therefore allows humans to survive and breathe. And we'll explore more about how water's specific heat capacity allows humans to breathe later on this presentation. But essentially, an introduction to what we're going to talk about is that everything on Earth is connected. So even with a large specific heat capacity of water, ocean temperatures are still rising in climate change. And while the oceans are only slightly warmer, even the smallest and tiniest increase in water temperature can lead to water alterations across the world. And these rising ocean water temperatures can disrupt sea life, as some organisms are not built to survive in such high temperatures of water. Some of which, a huge example of this is coral reefs, where coral reefs are important to provide shelter for other sea life against predators, so they're important to sea life. And they're also largely responsible for controlling how much carbon dioxide is in the ocean water. So without coral reefs, the carbon dioxide levels in the ocean will increase, which can be detrimental for all living things. And coral reefs remove carbon dioxide. They remove more carbon dioxide than they add, which is an important and essential thing for humans, where humans breathe in oxygen and release carbon dioxide. So the less carbon dioxide they get in themselves, the better. Additionally, photosynthesis also performs a similar function as coral reefs do in some way, because it produces oxygen and uses up more carbon dioxide, which is definitely extremely useful and essential for humans. But photosynthesis only occurs during the day, since the plants need the sunlight, hence energy to photosynthesize. So since photosynthesis only occurs in the day, one reason why coral reefs are so important is because they perform their functions at night. So they perform the function to remove more carbon dioxide than they add. So they're essentially doing the same thing as what plants do in photosynthesis, which is using up more carbon dioxide to benefit human breathing. And additionally, coral reefs are responsible for maintaining carbon dioxide levels in the ocean water. Where if the coral reefs die out, so hence the carbon dioxide levels in the ocean increase, many sea life won't be able to handle that. And as a result, other sea life will die out as well. And the other sea life won't be used to such increase in the carbon dioxide levels in the water. So essentially, coral reefs dying out due to climate change despite water's specific heat not only impacts other sea life, but it impacts human life as well. And essentially, the point of this slide is that we are all connected in this ecosystem. And which is why so what you'll basically see on the slide is a picture of coral reefs. So there's healthy and unhealthy coral reefs. So the healthy ones are the brown ones on the right side, and the unhealthy one, which is also known as coral bleaching, is on the left side. So those are the white ones. So coral bleaching essentially occurs when the environmental conditions change. So coral bleaching is when the coral reefs turn white, since the coral reefs will expel the algae living in their tissues when the water temperatures in the ocean is too warm and it increases. And these bleached corals increase susceptibility to disease and increase their mortality rate. And coral bleaching prevents them from reproducing too much. So coral bleaching is essentially slow death, which will, as I mentioned earlier in the slide, negatively impact all living things. Okay, so organisms in the sea also produce over 50% of oxygen that animals on land need to breathe. So these sea animals get the oxygen from the ocean water. So by increasing the temperature in the ocean water, many marine organisms won't be able to live, leading to a decrease in the production of oxygen, which makes it harder for humans to breathe through cellular respiration. And this basically goes off of the coral reefs example on the previous slide, where what we're doing to our climate directly negatively impacting the sea life, where if the sea life gets impacted, then that also impacts humans. So how is all of this related to the specific heat capacity of water? So the point that we're trying to make is that despite the high specific heat of water, water temperatures in the ocean are still rising due to increased greenhouse gases in the atmosphere from fossil fuels. So just imagine how much damage humans are doing to the planet when such, when such a warm and hot substance, such as fire, as mentioned in the previous slides, does not impact water's temperature, then how are humans increasing the temperature? So just think about how much fossil fuels are being consumed to increase the ocean's temperature by so much that it's detrimental to all life on the planet. And our country is the worst when it comes to consuming fossil fuels. As the United States consumes the highest amount of fossil fuels per capita. And what humans think isn't directly affecting them is indirectly affecting them, because high water temperatures that humans are causing are part of climate change, which will impact the sea life, and the sea life will impact humans as well.